Hello everyone, today we're going to be working on example 6-4 and this example is asking us to determine the force in each member of the truss shown below. So to start off this example, what we're going to do first is we're going to take a look at the figure and determine how many reactions there are going to be and then solve for those reactions. So if we take a look at point A, we have a roller, meaning that we're just going to have one reaction, which is usually, it's vertical to that, but in our point of view, it will be like a horizontal reaction. I'm going to assume that this reaction is going upwards. I'm going to call it A sub X. Then at point B, we have a pin support, meaning we're going to have two reactions. And for that force that is vertical to the support, I'm going to assume that this one's going to the right. Since it's horizontal for us, I'm going to call it B of X. And then for that one that's parallel to the floor, I'm going to be assuming that it is going upwards. And I'm going to call it B sub Y. So now that we know how many reactions there are, now I'm going to proceed to find their values. So to start off, what I'm going to do is I'm going to take the sum of the forces in the Y direction since there's only two vertical forces, the 300 pounds and the B sub Y, meaning we could solve for B sub Y. If we solve for B sub Y, we end up getting that B sub Y is equal to 300 pounds. Since we got a positive number, means that we assumed correctly. So we do know that that reaction will be going upwards. So now we could come over here and add that it has a value of 300 pounds. So now since we have two unknown horizontal forces, if we were to take the sum of the forces in the x direction, we'd have two unknowns, so we wouldn't be able to solve. So what I'm going to do is I'm going to take the sum of the moments about point B, because that way B of x would not be creating a moment, B of y would also not be creating a moment, meaning that only the 300 pounds at point D and A of x would be creating a moment, meaning I'd be able to solve for A of x. Sign convention, counterclockwise, positive. The sum of the moments about point B have to equal 0. Like I said, we're only going to have two forces creating a reaction. So first we have our A of x. We could see that we assume that it's going to the left. So that means it's going to be creating that clockwise moment, meaning a negative moment. And remember, the moment is equal to the force times the distance. The force is what we're trying to solve for, and the distance is 3 feet. So negative moment of the force AX times the distance, 3 feet. From there, we have our 300 pounds that is going downwards. So we know that's going to be creating that counterclockwise moment, meaning positive moment. From there, our force is 300 pounds and our distance is 2 feet plus 2 feet, giving us a total of 4 feet. Positive moment, force times the distance, and we know all of that has to equal 0. So if we were to solve for A of x, we'd end up getting that our reaction A of x is equal to 400 pounds. We ended up getting a positive number, meaning that we assumed correctly at the beginning, so we know that that reaction will be going to the left. From there, since now we know one of the unknown horizontal forces, we can now proceed to taking the sum of the forces in the x direction to be able to solve for now b of x. So now sign convention to the right is positive. You know that the sum of our forces in the x direction have to equal 0. From there, we just have our 400 pounds that's going to the left that we just solved for, and then b of x, which we assumed is going to the right. So we have negative 400 pounds plus b of x has to equal 0. So we end up getting that b of x is equal to 400 pounds as well. We got a positive number, meaning we assumed correctly. So we do know that that reaction will be going to the right. So now with that, we have determined the values of all of our reactions. So now that we know all of the reactions, we can now proceed to determining the forces of the members of the truss. So remember, the first step is to determine how many reactions there are and then solving for their forces. So I'm going to put this off to the side. And now that we know all of our forces, we can now proceed to finding the forces of the members. So how I'm going to determine the forces of the members of the truss is I'm going to be using the method of joints. So that's going to be our second step. Using method of joints. So I'm going to take a quick glance at this figure, and based off of my opinion, I'm going to start off with joint B, because if I start off with joint B, I'll be able to determine two members with one joint. So I'm going to start off with that one. Joint B. So if we were to draw out joint B, we'd have our joint B right there. We'd have our reaction B of Y, yeah, going upwards with a value of 300 pounds. From there, we'd have our reaction B of X going to the right with a value of 400 pounds. From there, we have that bar of AB going downwards, and then we have bar BC. So I'm going to assume that both of these bars or members are both in tension, which is why I'm going to be assuming that they're going away from that joint. But we'll soon figure that out if we are right or wrong. So I'm assuming that they're in tension. So for our bar AB, that means that it's going to be pointing downwards. So force, I'm going to call this force of bar AB. From there, we have our force of a bar BC, and I assume tension, so away from that joint. So now that we have that, what I'm going to do now is I'm going to take the sum of the forces in the x direction. As you guys could see here, we have our 400 pounds that's going to the right, so that'd be a positive force. And then from there, since we assume that our force of our member BC is going tension, in this case, it is slanted to the left, meaning that it's going to be a negative force. And then from there, we're going to go back up to the figure. As you guys could see, we know that this side of the triangle has a length of 3 feet. We know that this side of the triangle has a length of 4 feet. That means this side would be 5 feet. So we have a 3, 4, 5 triangle. So we're going to use that to determine the X and Y component of the force of the bar BC. So since we're dealing with the sum of the forces in the X direction, we're going to be finding the horizontal component to this force. So that means that we're going to be multiplying the force of BC by 4 over 5. So we have 4/5 times the force of BC is equal to 0. From there, if we were to solve for the force of BC, we end up getting that the force of the bar BC or member BC is equal to 500 pounds. We end up getting a positive number. And remember, when it comes to determining the forces of a member of a truss, if you get a positive number, that means that it's in tension. Meanwhile, if you get a negative number, that means it is in compression. So since we got a positive number, that means it's in tension. From there, now we're going to take the sum of our forces in the y direction. And here we have our 300 pounds going upwards. Since we do know that the force of the bar BC is in tension, that means it's going slanted downwards, so negative force, and we assume that the force of the bar or member AB is in tension, it's going to be going downwards, so another negative force. So we have 300 pounds. From there, we already know the value of the force of the member BC, but to determine that vertical component of it, we're going to multiply that force by 3 over 5. So negative 3/5 times 500, and then minus the force of the member AB is equal to 0. From there, if we were to solve for the force of the member AB, we end up getting that the force of AB is equal to 0. So if we go back up here to the figure where we're going to show our final answer, I'm just going to quickly start putting some information. We know that this bar right here, 0. It has a force of 0. From there, we have the member BC having a force of 500 pounds in tension. From there, I'm going to go back up to the to the figure. And now I'm going to be doing the method of joints on joint A. If we were to draw joint A, on joint A, we'd have the reaction of 400 pounds. From there, we would have the member AB, but since we already figured it out that it has a force of 0, we don't really have to draw it out, but we could. But we already know that that has a force of 0. So I'm going to just draw it in red, 0. From there, The member AD, I'm going to assume that it's in tension, so away from the joint. That would be the member of the bar AD. And then from there we have the member AC. So now from here, what I'm going to do is I'm going to take the sum of the forces in the y direction. But if you guys could already see, since this force right now has a value of 0, in a way, it doesn't really exist. So because of that, you guys remember that there's two cases when determining forces of a member of a truss. The first case is usually talks about how when only two members meet a joint at an angle other than 180 degrees and no external force or reactions exist at the joint, then both of those forces are, so both of those bars are zero, are equal to zero. But here we have what's known as a case two, which is basically when three members meet at a joint and two of them are collinear, which would be our 400 pounds and our force of AD. And then no other external force or support reactions exist at the joint. Here we did have this one, but we do know that it has a force of zero, so it's practically not there. Um, then the force in the non-collinear bar is equal to zero. So force AC, because of case two, would be equal to zero. You don't have to show the work for it, but you could usually just quickly put that that's equal to zero. And if you need to explain, you could just put because of case two. But I'm just going to be showing the work to it if you guys would like to show the math behind it in a way. So to do that, we take the sum of the forces in the y direction. From there, we just have the only forces in the y direction is just our force AC, but we're quickly gonna go look at this. Once again, we know that this triangle is a 3, 4, 5 triangle, so we're gonna use that right here. We know 3, 4, 5. So since we're dealing with the forces in the y direction, we're going to be multiplying the force of AC by 3 over 5. So 3/5 times the force of AC. And since that's the only vertical reaction, we just have that is equal to 0. Hence why the force of the bar AC is equal to 0. So that's one way to show it if you guys want to show like the math behind to it in a way. But if not, if you guys are allowed to just quickly just know from like those cases to help you guys out, determining like bars of the truss, you guys could just skip that part and just put that the bar AC is equal to 0. Now, what I'm going to do is I'm going to take the sum of the forces in the x direction to determine for the force of the bar AD. We have 400 pounds going to the left, so that's negative. From there, we do know that our force of our bar AC is equal to 0, so that means that for its horizontal and vertical component, there is no force, so it's also going to be 0. And then from there, since we assume that our force of the bar AD is in tension, that means it's going to the left. If we solve for the force of the bar AD, we'd end up getting that the force of AD is equal to negative 400 pounds. Remember, if we get a negative number, that means that it is in compression. here. And then from there, we figured out that this part is 400 pounds, negative 400 pounds in compression. From there, now I'm going to be I'm going to be using the method of joints on joint D, so that way we could solve for this last bar CD. So if we were to draw joint D, we'd end up getting that 300 pounds coming down from joint D. From there, we know that our bar AD is in compression, meaning that it's always going towards the joint. So towards the joint, so in this case to the left, with a force of 400 pounds. And then from there, I'm going to assume that our force of our bar CD is in tension, so away from the bar. From there, looking again at the triangle, once again, 3, 4, 5 triangles. So that means 3, 4, 5 triangle. From there, you could either take the sum of the forces in the y direction or in the x direction. It doesn't matter, because since the force of the bar CD has both a horizontal and a vertical reaction, solving for one of them would be giving you the same answer in the end. So in this case, I'm just going to be taking the sum of the forces in the x direction, but you could also take the sum of the forces in the y direction, and you should get the same answer. Since we're trying to determine the horizontal component of this force, we're going to be multiplying the force by 4 over 5. From there, if we were to solve for the force of CD, we end up getting that it has a value of 500 pounds. Since we got a positive number, that means that it is in tension. So with that, we have found all of the forces of each of the members of the truss. So once again, we're going to go up here, just write out that the bar CD has a force of 500 pounds as well in tension. And then from there, I'm just going to quickly draw in the reactions as well. So once again, how I started off this example was first determining how many reactions there were in the figure, from there solving for the values of each reaction, and then from there using method of joints one by one to go determining each of the forces of each of the members of the truss. Thank you guys so much for watching this video. Please feel free to like this video if you guys found this video helpful, and also feel free to subscribe to our channel if you guys would like to see more videos like this.